organizing data, we look at what a frequency distribution is. It's just a way we can organize raw data in a table form. And so for this table, we don't have the raw data, but looking here at the third column, I know that this data set represents 25 individual values, because that's the total. And I also know that the data is based on blood typing. I mean, you may not know that, but the A, B, O, and AB are the 4 different types that your blood type could be. And this particular table is called a categorical frequency distribution. It displays categorical data. So, and that's something that comes from chapter 1 in your reading. Categorical data is any data that can be nominal or ordinal. And so that information comes from chapter 1. Nominal data, kind of to reiterate what that is anything that can be classified by an attribute or a characteristic. In this case, blood typing, that's an attribute or a characteristic. You can either be A, you can be B, you can be O, or you can be AB. And then ordinal data is any type of data that represent categories that can be ranked. So if you think about, let's say you took a quality control survey. Let's say you went to Chick-fil-A or Target and you bought something and they sent you a survey based on your responses. If you were either very dissatisfied all the way up to highly satisfied, that's a category that you were either very satisfied with their service or very unsatisfied, but those categories can be ranked. So both nominal and ordinal data are just some type of a category, but nominal data is not ranked and ordinal data is ranked. So that's the main difference. But that's just information from your chapter 1 reading. And we're going to look at how we construct a categorical frequency distribution here in a little bit. So if we look at this example, so our first example, constructing a categorical frequency distribution. So this information here is about a survey that was collected on how much people trust the information they read on the internet. And so here, this is our raw data, and we would like to take that raw data and we want to organize it into non-overlapping categories. In this case, we want to use the information provided, which is that the letter A represents always trust, the letter M represents most of what they trust, H is half of what they trust, and S is a small portion of what they trust. And so these are non-overlapping categories because someone can't trust in all that they read, and at the same time, they can't trust some of what they read. So you either fall into one of these 4 categories. And so what a tally is just the number of times. In actuality, a tally and a frequency are more or less the same thing. So how many times does the A appear in this raw data set? How many times does the M appear in the raw data set? And how many times does H and S appear? So if we go through and kind of do this part really quickly, we can see that there's 4 A's. So I would put 4 marks for tally. Frequency is 4. And then 4 out of the 40 represent the number of 4 out of the 40 represent the number of A's, which is about 10%. So 10% of the distribution of this information represents individuals who trust everything that they read on the internet. And then we do the same thing for each one of the other categories. So we look at H, and I'm looking at H next because it's probably the next most least occurrence, well, H or S, and I usually save the largest set for last because it'd be easy to find that because you just subtract out the rest. So I went through and highlighted all the H's, and there are 6 H's, and so we calculate the percent of that, so 6 out of 40, and we get 15%. And then we do the same thing with the S's. There were 2 S's, and so 2 out of 40 is 5%. And then, so to quickly find the M's, that wouldn't be difficult because the M's are what's left. And I found that by taking, just subtracting 12 from 40, and that gave me 28 out of 40. And so we can see that that's 70% of the data. And what we would like to make sure that we have 100% represented here. So 10 and 70 is 80, and then 95 and 5 is 100. So we have 100% of the data represented here. Now, after we take that organized data, we can then use it and we can represent it in some sort of graphical form. And this is actually comes from section 2.3, so I'm introducing it into 2.1 just to kind of tie that information. Normally, you would see the graphical representation of organized data in some type of a scholarly journal or a newspaper or a magazine. We're not really going to display an actual table of data somewhere for an audience to read. This bar chart here, or Pareto chart, is probably more conducive to someone looking at and drawing information out. We can clearly see that M has the highest frequency of occurrences of people that they're trusting the internet. Now, one thing we would want to have is probably what M, S, A, and H stands for, kind of off to the side, but I've left that part out. And we can also and this type of chart is only for categorical data. And we can tell it's non-overlapping, so none of the bars interact with each other, and so the categories are separate. We can also do a pie chart as well, which shows us the percentages. So there's several different ways that we can organize that data to help a reader kind of digest or taking that information a lot more easier than just showing them the raw data set. Now, also in 2.1, we look at another way to organize data, still in tabular form, but we look at a grouped frequency distribution. So oftentimes when our data set is numerical and it's a very large data set, we can group those into classes as well. And again, these are non-overlapping classes, like with the categorical, except it's numerical. So a class limit is how we are going to separate or disperse this data into this distribution, into this categorical, into this grouped frequency distribution. So in the problem, it says the number of stories in each of a sample of the world's 30 tallest buildings follows, and we want to construct a group frequency distribution and a categorical and a cumulative frequency distribution. That we're actually going to do later in the next section. So we're only focused on constructing in this section either a categorical distribution, which we just did, and then a group frequency distribution. Now this tells us we want to construct it with 7 classes. And that's what this table represents here. This blank table we're going to complete together. So in order to do that, we have to take this raw data that so far is unorganized, and we want to organize it in a way that all 30 of these values fit into one of the class limits we're going to construct. To construct the class limits based on the 7 classes, we need to find something that's called the class width. That class width is going to help us determine which one of these values are going to be placed into these class limits that we need to construct. So to find the class width, we look at the range. And so if you were probably from your previous knowledge, you have some concept of range. The range is the distance from the largest value to the highest value. And so that's basically how dispersed our data set is. And so in this case, we find that range, and then that's going to tell us the spread of our data. And we're taking that spread and we're dispersing it into these 7 classes we need to create. So for us, the largest value is 110, the smallest value is 54, and we need to get that number for our range, which is 56. And so in the problem, it's telling us to use 7 classes. So we have a spread of 56 stories essentially, and we want to divide that spread across 7 different groups or 7 different classes we're going to create. And so that value is 8. But anytime we construct a group frequency distribution, we always have to round this value up to the next whole number. So I know this is already a whole number, but even if it were 8.1 or 8.5 or 8.9 or just 8 like it is now, we always have to round that value up to the next whole number. So the value that we're going to use for our class width is going to be 9. So and this just helps us determine how large to set our limits. So to construct our limits, and remember, we're using this class width to construct the limits, and we're going to create non-overlapping kind of groups of numbers here, we're always going to start with our smallest value. So our 54 is our smallest value, and then we're going to use our class width of 9 to find the next number to use. And so based on what we calculate for our class width and what we start with is going to set the information for our class limits. So I'm essentially just taking this 9 and I'm adding it each time to the previous number. And this number is called our lower bound. So every number we find here is going to be considered the lower bound for that class limit. So if I keep adding 9 each time, these are the lower bounds for my class limits. Now, if I want to find the upper bound, and we have to consider that each of these class limits are non-overlapping. So 54 is the lower bound for my first class, and then 63 is the lower bound for my second class. So if I want to find the upper bound, it would be 62, because it's the next whole number less than 63. And then if I keep doing that process, this is 71, because it's the next number before we get to 72, and these are non-overlapping, and then 80, and then so on. If we notice, this retains the same pattern, if we add 9 to 62, we get 71. If we add 9 to 71, we get 80. If we add 9 to 80, we get 89. And so it kind of has the same property that we used earlier. Now, before we go any further and talk about a class boundary, we want to make sure that every single number from the smallest 54 to the largest 110 can fit somewhere into these limits we just created. If for some reason we couldn't, and mainly it's the largest number, which is why we rounded this up. If we didn't round this up and we started with 8, then we wouldn't be able to include the 110 in one of our intervals that we constructed, one of our class limits. So we're good there. The smallest value fits in the first group or the first class, and the largest number can be placed in the last group. So our class boundary, and this is a concept from chapter 1. So when you're reading from chapter 1, to construct the boundary, because these are whole numbers, then we want to create intervals that now they have an overlap from the first limit to the second limit, from the first class limit to the second class limit, and then from the second class limit to the third class limit. So when you're reading from chapter 1, it talked about how you construct a boundary. For any whole number, we want to add or subtract 0.5 to that value to construct our boundary. So for the first one here, my class boundary would be 53.5 to 62.5, because I'm subtracting 0.5 from 54 and I'm adding 0.5 to 62, and that's just extending out my class limit to construct this class boundary. And we're doing that because the class boundary is actually going to be useful in constructing a certain type of graphical display that we'll talk about in the next section, section 2.1. So if I keep with that process and I look at the next one, and if I subtract 0.5 from this number, I get 62.5. So here we have an overlap now. These two values need to be the same. So we can, when we get to section 2.2, we get to talk about what type of graph we can utilize for this. And then I add 0.5 to this number, and I get, say, 1.5. So I keep along that process until we complete this distribution, and we see that now the upper boundary and the lower boundary here are the same each time. The upper boundary and the lower boundary are the same. The upper boundary and the lower boundary are the same. So these are our class boundaries. Those are more or less going to be used later in section 2.2. Now the tally and the frequency are no different from the categorical distribution that we constructed. We want to look at what values in our raw table and our raw data set, and that should be data, not date, but that's okay. And our raw data set can fall in between the interval from 54 to 62. So I go through and I look in my data set, and everywhere I find a value that can fall between 54 and 62, I keep a record of it. So there were 7 values that I found between from 54 to 62, and those 7 values I can place into this limit. I do the same thing for the next one, from 63 to 71, and they're actually 6. So, and I'm highlighting them so you can see them a little easier, how I'm finding those numbers. And I do the same thing from 72 to 80, and then the same thing from 81 to 89, and I find all those values. And once this process is complete, this will be a grouped frequency distribution. And of course, later we look at how we can turn this information into some type of graphical display, like we did with the categorical.